Hi everyone, it's Tara. Welcome to my little YouTube channel where I like to goof around. This video is another room walkthrough for TryHackMe on the DevSecOps learning path. This video is a room walkthrough of the Intro to Pipeline Automation room. I just got done playing it. It is a good room. It's another introductory room with a lot of reading, a lot of terminology, a lot of that kind of thing, but definitely getting into topics that I personally like and find very interesting. And then there is one little hands-on activity at the end. This is the first room in the security of the pipeline module for the learning path. And with all of that said, I hope you enjoy the video. And here's just a quick reminder of the DevSecOps learning path. So we finished the secure software development module, and there are videos for all three of these rooms on the channel now. And then now we're going into the security of the pipeline module. This video covers the intro to pipeline automation room, which was great fun. And the other two rooms in this module are going to be the source code security room and then the CI, CD, and build security room. So the intro to pipeline automation room walk through a lot of terminology and stuff like that. And then these rooms I think are gonna have more like the activities. And then there are 3 more modules to come after that. So let's get to work. I successfully made it into the intro to pipeline automation room. So that's step 1, I guess. This room provides an introduction to DevOps pipeline automation and the associated potential security concerns. Task 1, of course, is our introduction. Humans are always looking for simpler and more efficient ways to do things. Just as we started programming and developing software, we were looking for ways to automate some of the tasks. Today, automation is heavily ingrained in the software development lifecycle, the SDLC, which now we know all about the SDLC, and DevOps processes. While this is incredibly good for production, allowing for faster development and deployment, it does, however, introduce new security risks. When these processes are manual, meaning like different processes associated with software development and deployment, an attacker would have to compromise the credentials or workstation of the individual that performed that manual part of the process. However, with automation, an attacker can now just go after the pipeline itself. There's no human stage they have to worry about. This room will teach you about the following concepts: introduction to DevOps pipeline, introductions to DevOps tools and automation, and introduction to security principles for the DevOps pipeline. All sounds interesting. This is the introduction room. As such, most of these concepts will only be introduced in this room and then will be covered in more detail in the rest of the rooms in the module. And the pattern seems to be so far that the introduction rooms have a lot more reading and then answering questions. Not that there's nothing wrong with reading, and then as we get past the introduction rooms, we get into like more of the hands-on activities. So anyway, we are ready to learn about pipeline automation and how to make sure it is secure, exclamation point. So I will hit completed and move on to task 2. Before learning about automation security, we should start by first defining the pipeline and showing where automation can take place. The diagram below shows what a typical pipeline can look like, as well as the software that could be used for this purpose. So this is their stunning visual graphic. I like the colors a lot. That shows what a typical, they use the term DevOps pipeline, but like I'm thinking CI/CD pipeline could look like. So starts with dependency management, and then you have your source code storage and your version control. You have continuous integration, which involves a lot of automated testing as you're integrating new code into the code base. And then you deploy your code to the different environments. So this would be like a test environment, a staging environment, a production environment, for example. For each of these items, we will look at what they are, the common tools used for them, an introduction to their security, and a case study of what can happen when security fails. Nice. I like the sound of that structure because I like case studies because I'm a nerd. Each of these components will be reviewed in depth in the coming rooms of the module. Where in the pipeline is our end product deployed? So I think this would be in this context, environments here. Let's see if that's right. Environments. I don't know why I had to sing it. All right, so that is task 2. And let us move on to task 3, which looks like is about source code and version control. So this part of the pipeline, the source code and version control. All right, so it says, let's take a look at source code and version control. This is the start of our pipeline. We need a location where we can store our code. Furthermore, we often want to keep several versions of our code since we're continuously making improvements and adding features to the code base. So we need to think about source code storage. We need to consider several things when deciding where to store our code. How can we perform access control for our source code? How can we make sure that changes made are tracked? Can we integrate our source code storage system with our development tools? Can we store and actively use multiple different versions of our source code? Should we host our source code internally, or can we use an external third party to host our code? Which I imagine most teams are probably opting for this, are using third party solutions such as GitHub. The answers to these questions will help us choose the correct storage code solution for our project. Let's talk about version control, everyone's favorite topic. We need version control for two reasons. We're often integrating new features in our software. Modern development approaches such as Agile means we're constantly updating our code. To keep all these updates in check, we need version control. An entire development team is working on the code, not just one developer. So like in a typical project, it's not just you making updates to the code and saving them. You're making updates while the other developer on your team is making updates, while the other developer on your team is making updates, and you need a way to all work together as you do that. To ensure that we can integrate the changes from multiple developers, version control is required. Version control allows us to keep multiple versions of the code. So this could be specific versions that each developer is working on, but it could also be completely different working versions of our application, including minor and major versions. And then we have common tools. The two most common source code storage and version control systems are Git and Subversion, SVN. Git is a distributed source control tool, meaning that each contributor will have their own copy of the source code. On the other hand, SVN is a centralized source control tool, meaning the control of the repo is managed centrally. So that's what centralized means. I've always just used Git. I think Git pretty much like makes the world go round at this point. And I don't know if I'm alone in this or if this is embarrassing to admit, but I'm going to say it anyway. I do really feel that when I was first learning programming, when I was learning cyber and IT and learning how to really code, I feel like Git and version control was one of the things that was the hardest to like learn conceptually until you are actually just doing it, until you have experience using Git and using version control in a team setting where more than one developer is working on a shared project. I think it is really hard to learn Git until you have been in that situation at least once. At least for me, it really was, where usually I don't have so much trouble grasping something before I've done it. Git, I always tried to understand what it was, but I didn't really learn it well until I was committing code to a shared repository with different developers, different branches, etc. And one time, like when I used to work at Amazon, I remember I spoke on a panel of advice for incoming interns who were going to be in like technical roles. And I remember one thing I said on that panel was, I think it's a really good idea to learn Git as early as you can and to get as good at Git as you can. Sorry for the tongue twister. Because if you are the person on the team who is really good at Git and can solve Git problems when they come up, you can very easily become like a go-to person. So the sooner you actually start just hands-on practicing using Git, the better. Don't try to like understand it just by reading it. Find a way to practice doing it hands-on. And if you're new to all this, you definitely can learn version control and you will learn it. And it's one of those things where once you just start using it every day, it quickly goes from you didn't understand how it works to now you have like way more Git commands and Git routines memorized in your head than you would care to admit. You'll definitely pick it up, but hands-on practice is like really the way to go if you're learning Git and version control for the first time. But you know what? When is hands-on practice really not the answer, now that I think about it? So now we are going to talk about GitHub. GitHub is by far the largest provider of internet hosting for software development and version control using Git. You can create a GitHub account and use that to manage your source code repositories, or repo as we like to abbreviate it. However, you could also host your own Git server using software such as GitLab. For SVN, the two most popular tools are Tortoise SVN and Apache SVN. It should be noted that source code storage solutions such as GitLab provide much more features than simple storage and version control. Today, these tools can be used for almost your entire pipeline, meaning I think these tools meaning GitHub and GitLab. And this is a topic I could like honestly talk about GitHub and GitLab for far too long, so I will try to control myself. But I have used both GitHub and GitLab in professional settings and for personal projects. I really like both of them. I think to have a GitHub account especially is not really optional. You definitely want to have one. And there are things I really like about each of the platforms. I personally think that what is going to differentiate one from the other, GitHub versus GitLab, isn't going to be the function like they're saying here, like version control and just basic like Git functions and shared code repositories. It's the different CI/CD and DevSecOps features and functionality that differentiate the two platforms now, especially if you are starting to learn about GitLab. One thing you will really notice about GitLab, at least at the time I'm making this video, is that GitLab is all in branding wise on they want to be the DevSecOps platform. So since we're learning about DevSecOps in this learning path, like I bet even if I go to their website right now, like see, so right here, this is the first thing it says. GitLab is the most comprehensive AI-powered DevSecOps platform. Oh, so they're AI-powered as well. But this is the branding I've always seen for them the last few years, is that they want to be associated with DevSecOps platform in your head. Balancing speed and security in a single platform, etc. GitHub has a lot of the exact same like DevSecOps functionality, but GitLab really wants you to associate them in your head with DevSecOps platform. So that is the play that they're making. And then also just totally shallow side note, I absolutely love GitLab's color scheme and their branding and their design. And I love their 4-point stars that they use on everything. I think their branding is really beautiful. But now mostly in my day-to-day, I use GitHub most frequently. Anyway, I like both of them. I don't have a strong feeling one is better than the other. So that was already like second tangent for this room. And then let's move on to security considerations. Our source code is often our secret sauce. As such, we want to make sure it is not exposed. This is why authentication and access control for our source code is so important. We also want to make sure that changes and updates are adequately tracked, allowing us to always go back to previous versions if something happens, right? So that's part of the beauty of version control, is that we have all these different versions. And so when something goes wrong and something new we're doing or whatever, we have a different version readily available to revert back to. However, we also need to be careful about what we store as part of our source code. Source code cannot be fully secret since developers need to access it, or as such, we should be careful not to confuse source code storage with secret management. We need to make sure not to store secrets such as our database connection strings and our database credentials in our source code. Since we keep all versions of our source code, even if we remove the secrets in a newer version, they will still be exposed in the previous versions. So what this looks like a lot like a common trap people fall into, including myself many times, is that we kind of like do something hacky or like cheat when we're just starting to work on a project. It's not near production yet. We're trying to test something really quick and we want to save time. So we maybe like put the database connection string right into the code, and then we forget, right? Like our brain moves on. We forget somehow we never meant to commit that secret to the code repository, but we do. And then we realize our mistake. Or like another thing that happens often is maybe you accidentally commit a local file that is meant only to stay on your workstation. You accidentally commit that file to the shared repository, and then you realize your mistake. So you try to fix it by deleting the string out of the code or by deleting the file out of the repository. And then the most current version of the code does not have the secret. However, anybody that has access to that repository could simply revert back or pull that old commit that had the bad thing in it. And then it's the same as if it had never been deleted. So that is the thing about Git. You can't fix a leaked secret just by making a new commit. It's going to take like a more nuclear solution than that. And here's a perfect case study. Git never forgets. As mentioned before, version control can end badly for us if we make a mistake. This is a common problem when using the version control tools such as Git. There is a saying, Git never forgets. Code is committed to a Git repo. When this happens, Git determines the changes made to the files and creates a new version based on those changes. Any user with access to the repo can look at your historical commits and all the changes that were made, so they can still see the old secrets. What often happens is a developer accidentally commits secrets such as credentials or database connection strings to a Git repo. Realizing their mistake, they delete the secret and create another commit. However, the repo will now have both commits. I'm laughing because I realize I accidentally once again jumped the gun. If an attacker gets access to the repo, they could use a tool such as GitLab, which would scan through the commit for sensitive information. Even if the information no longer exists in the current version of your application, the tools can scan through all the previous versions and find your secrets. So good case study, good little task there. And here are our questions for task 3. Who is the largest online provider of Git? So that would be GitHub. What popular Git product is used to host your own Git server? And that is GitLab. And then what tool can be used to scan the commits of a repo for sensitive information? And there's a lot of tools out there that could do that, but I think in this context, they're referring to GitLab. All right, so that is task 3, and then we'll jump right into task 4, which is about dependency management. Let's see what we got here. Okay. Oh, beautiful, colorful graphic. I love it so much. Let's talk about dependencies. Although we may think we are writing a large amount of code when we develop, the truth is that it's only the tip of the iceberg. Unless you are coding in binary, which you're probably not, chances are you are actually only writing a fraction of the actual code that your application uses. This is because a lot of the code has already been written for us in the form of libraries or software development kits or SDKs. For example, I almost daily use the AWS SDKs, which is a bunch of libraries they've already put together. I'm not writing any of the code. I'm just importing it into my application and then writing a tiny bit of code to use their existing code. And even variables like string in an application have an entire library behind them. The management of these dependencies is a vital part of the pipeline. So we have external versus internal dependencies. External dependencies are publicly available libraries and SDKs. These are hosted on external dependency managers such as PyPy for Python, NuGet for .NET, and Gems for Ruby libraries. Internal dependencies are libraries and SDKs that an organization develops and maintains internally. For example, an organization might develop an authentication library. This library can then be used for all applications developed by the organization. And the authentication library might have like its own team that's what they work on, and your team just uses that library in whatever application you own and are responsible for. There are different security concerns for internal and external dependencies. So some concerns for internal dependencies would be libraries can often become legacy software since they no longer receive updates, or the original developer who really knows about them and made them has left the company. The security of the package manager is our responsibility for internal libraries. A vulnerability in an internal library could affect several of our applications since we use it in all of them. For example, if every application in our company uses that authentication library and something is wrong with it, there's something insecure, then the blast radius is really big. And then external security concerns, since we do not have full control over an external dependency, we must perform our due diligence to ensure that the library is secure. If a package manager or content distribution network, a CDN, is compromised, it could lead to a supply chain attack. And then external libraries can be researched by attackers to discover zero-day vulnerabilities. If such a vulnerability is found, it could lead to the compromise of several organizations at the same time. So not only do you have to worry about 0 days and newly exploited vulnerabilities in your own code that you're writing, any external libraries that you use could also have vulnerabilities that hackers find and exploit. And then, so here are some common tools. A dependency manager is also called a package manager, and it is required to manage libraries and SDKs. As mentioned before, tools such as PyPy, NuGet, and Gems are used for external dependencies. The management of internal dependencies is a little bit more tricky. For these, we might use tools such as JFrog Artifactory or Azure Artifacts to manage our internal dependencies. Security considerations. Some of the security considerations have been mentioned before. However, the primary security concern is that dependencies are code outside of our control. Especially in modern times when so many different dependencies are used in a project, it is incredibly hard to track dependencies. If there are any vulnerabilities in these dependencies, it could lead to vulnerabilities in our applications. And then we have a case study here. So the case study is Log4Shell. A 0-day vulnerability was discovered in Log4j dependency in 2021 called Log4Shell. Log4j is a Java-based logging utility. It is part of the Apache Logging Services and a project of the Apache Software Foundation. So I bet this is in a lot of code in a lot of places. The vulnerability could allow an unauthenticated attacker to gain remote code execution on a system that makes use of this particular logger. The true issue, this small little dependency was used almost literally everywhere. I bet it was, as shown by the XKCD cartoon. So this like all modern digital infrastructure and then is all propped up on this one. Looks like a project some random person in Nebraska has been thanklessly maintaining since 2003. And this is like the foundation of everything. This happens a lot. This is not an over-exaggeration. Have a look here to see how many products were vulnerable since they used this dependency. All right, Log4j affected, DB. And oh my God, this is, oh wow. This is just literally a bunch of different lists of organizations and companies that were made vulnerable because they were using this external dependency, the Log4j library. And there was so many of them, they literally had to split it up into different lists by letter. And look how long just the A list is. And we got like Amazon, 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 a bunch of the AWS services. It's actually really crazy. And this just shows the impact of what can happen, the rippling impact when a vulnerability is discovered in a dependency that all these other things depend on. So what do we call the type of dependency that was created by our organization? So that would be internal. What type of dependency is jQuery? That would be external. What is the name of Python's public dependency repo? That is PyPy. And what dependency 0-day vulnerability set the world ablaze in 2021? I love the dramatic language. It'll always get me. So the vulnerability was in log4j, but the vulnerability was called log4shell. So I think, oh, maybe not. Oh, but it's only 5 letters. So the answer must be log4j. All right, and that is task 4. So we will move right into task 5, which is about automated testing. Let's take a closer look at automated testing. In the old days, testing was quite a tedious and manual process. A tester would have to manually run and document every test case and hope that the coverage was sufficient to ensure that the application or service worked and would remain stable in production. However, in modern pipelines, automated testing does a significant portion of this. So we have different types of testing here. So unit testing. When we're talking about automated testing in a pipeline, unit testing will be the first type of testing that most developers and software engineers know and are familiar with. A unit test is a test case for a small part of the application or service. So the idea is to test the application in a lot of smaller parts to ensure each functionality works the way we expect it to, the way that it should. In modern pipelines, unit testing can be used as a quality gate. So test cases can be integrated into the continuous integration and continuous deployment CI/CD part of the pipeline, where the build will be stopped from progressing. The pipeline will fail if certain test cases fail. However, unit testing is usually focused on functionality and not security. Another common testing method is integration testing, where unit tests focus on small parts of the application. Integration testing focuses on how all these small parts work together. Similar to unit tests, testing will be performed for each of the integrations and can also be integrated into the CI/CD part of the pipeline. A subset of integration testing is regression testing, which aims to ensure that new features do not adversely impact existing features and functionality. So that's really important, obviously. However, similar to unit testing, integration testing, including regression testing, is not usually performed for security purposes. It's focused on functionality of the application. And then we have security testing. So if the first 2 types of automated testing are not for security testing, where are our security tests? There are 2 primary types of automated security testing. And so it looks like we're going to talk about SAST and DAST, which we covered in quite detail in the most recent room, which was like the SDLC room. So static application security testing, or SAST, works by reviewing the source code of the application or service to identify known sources of vulnerabilities in your code. So SAST tools can be used to scan the source code for vulnerabilities. They literally just like read your code. This can be integrated into the development process to already highlight potential issues to developers as they're writing the code. We can also integrate this into the CI/CD process, not as quality gates, but as security gates, preventing the pipeline from continuing if the SAST tool still detects vulnerabilities in the code that you have not somehow flagged as a false positive. So a SAST tool will have some sort of mechanism you can use to bypass a certain vulnerability in the code, or a certain something, whatever the SAST tool doesn't like. There's a mechanism to say, actually, this one thing, like, we're going to leave it in here even though you're flagging it. And you want to obviously be using that as little as possible. But in general, what you can do is set up your pipeline so that as you're trying to add new code to the repository, it goes through SAST testing. Oh, that's one of those things where the last word of the T in SAST is testing. So it goes through SAST, and if it doesn't pass SAST, you can fail the pipeline before the code even ever makes it into the repository in the first place. And then we have DAST, which is the dynamic application security testing. DAST is similar to SAST, but performs dynamic testing by executing the code. So as we know, DAST happens, your application is actually running. This allows DAST tools to detect additional vulnerabilities that maybe wouldn't be possible to detect just with the source code review. You need to have the application running to understand that they're there. One method that DAST tools use to find additional vulnerabilities, such as a cross-site scripting vulnerability, is by creating sources and sinks. When a DAST tool provides input to a field in the application, it marks it as a source. When data is returned by the application, it looks for this specific parameter again, and if it finds that parameter again, it marks that as a sink. It can then send potentially malicious data to the source, and depending on what is displayed in the sink, determine if there is a vulnerability such as cross-site scripting. Similar to SAST, DAST tools can be integrated into the CI/CD pipeline as security gates. And I hope we're going to get hands-on with this. I think we are, because I think there's a DAST room. And then penetration testing. So we know about penetration testing. Sadly, SAST and DAST tools cannot fully replace manual testing, such as pen tests. And there have been significant advancements in automated testing. And even in some cases, techniques were combined with more modern approaches to create new testing technologies, such as IAST, Interactive Application Security Testing, and Runtime Application Self-Protection, RASP. There's so many acronyms, and it will never stop. There will always just be more. However, the main issue remains that these tools, including these modern testing techniques, do not perform well against contextual vulnerabilities. Take the process flow of a payment, for example. A common vulnerability is when part of the process can be bypassed. For example, the credit card validation step. This is an easy test case to perform manually, but since it requires context, even DAST tooling will find it hard to discover the bypass. Because it's part of like a chain of events, a bunch of different components working together, it's harder to spot the vulnerability unless you're seeing it in the big picture context. Similarly, business logic and access control flaws are hard to discover using automated tools, whereas manual testing can discover them fairly quickly. It is not that automated tooling will never be able to find these flaws. It is just simply more cost effective to use manual testing because manual testing is better at it so far anyway. That's probably changing more and more though. And then let's see, common tools. There are several common tools that can be used for automated testing. Both GitHub and GitLab have built-in SAST tooling, for example. And then let's see, here is our case study. She cannot, oh my gosh, I'm sure this is like a reference. I'm already blowing it here. But case study, she cannot take any more, Captain. She's gonna blow. A common issue with SAST and DAST tooling is that the tool is simply deployed into the pipeline, even simply for a proof of concept. However, you need to take several things into consideration. Performance cost, integration points, calibration of results, quality, and security gate implementation would be things that you want to think about. The first and last point is very important and can be costly if ignored. The initial proof of concept of the tool should probably occur after hours, since it will have to scan through all your code. So when you first implement a SAST tool, right, it's gonna have a ton of code to catch up on. So you don't wanna do that like during your peak business hours where people are trying to work on the code, because the process could impact performance of your source code control tool significantly. It's gonna slow it down while it's trying to do all that scanning. Imagine this happening just before a big release and developers cannot stage and push their latest commits. The developers will probably be kind of pissed off at you and you'll be pissed off at yourself as well. And then furthermore, as more organizations move to a more agile approach to software development, most repos receive several hundred comments daily. If you introduce a new security gate, even just for a proof of concept that scans each merge request for vulnerabilities before approval, if we were to try to introduce a new security gate that scans each of those merge requests, this can have drastic performance costs on your infrastructure and the speed at which developers can perform their reviews and their merge requests. When introducing new automated testing tooling, careful consideration should be given to have a proof of concept should be performed to ensure that no disruptions are caused, but also to ensure that the proof of concept is representative of how the tooling is actually going to be used and how it will actually interact when you have it integrated into your company. I was just going to say, it's not easy to do. A fine balance to try and achieve. But you don't want to start off on the wrong foot by like ruining all the developers' day when you first implement your tool. So you want to be really thoughtful about it. What type of tool scans code to look for potential vulnerabilities? So that's SAST. What type of tool runs code and injects test cases to look for potential vulnerabilities? So that is DAST, Dynamic Application Security Testing. Can SAST and DAST be used as replacement for penetration tests? So I think we know the answer they're looking for here is nay, but that doesn't mean that that doesn't happen or that's not what some organizations are doing, because I think it probably is. So that was task 5, and now we will move on to task 6, which is about continuous integration and delivery, CI/CD. Now we're really getting into it, so let's go. In modern pipelines, software isn't manually moved between different environments. Instead, an automated process can be used to compile, build, integrate, and deploy new software features. This process is called CI/CD. And this says, note, the term CI/CD has changed quite a bit in recent years. Initially, the primary focus was just on making sure that development was performed using an agile approach, while delivery of the product still occurred using the waterfall model of only deploying first releases. However, during this time, it was common for CI/CD to mean continuous integration and continuous development. Quickly, it was realized that deployment itself could also be made agile, and the acronym changed to mean continuous integration and continuous deployment, with development now becoming part of the integration components, since you're always just developing and integrating new code and then continuous deployment. And then finally, they realized it is not just the deployment, but all aspects around the delivery of the solution and how we monitor it after delivery. And the acronym was again changed to finally mean continuous integration and continuous delivery. Wow, I had no idea about that. So I don't know, anyone who watched, I can't remember. I think it was maybe like the intro to DevOps room or something like that, where I was talking about debating with my colleagues what CI/CD stands for. I did not realize it was like a historical evolution, with continuous development being first iteration and then now continuous delivery being the last iteration of the term. So wow, that is very good to know. I'm going to sound a lot more educated next time I talk about that now. So you might hear these terms used interchangeably, but they all actually refer to the same thing. That's true. All right, so now that we talked about ad nauseum what CI/CD stands for, let's talk about what it is. Since we are constantly building new features for our system or service, we need to ensure that these features will work with the current application. Instead of waiting until the end of the development lifecycle, when all features will be integrated, we can now continuously integrate new features and then test them as they're being developed. So a feature is one part of what an application does. A good example would be like Instagram or any application. Even when your application is already existing out in the world, you're continuously adding new features. Like when Instagram wanted to compete with TikTok, it added Reels or whatever. And when it wanted to compete with Snapchat, it added Stories. Those are new features they're building, integrating to their existing product, and then doing a new release of a new version of the product. We can create what is called a CI/CD pipeline. These pipelines usually have the following distinct elements: a starting trigger, the action that kicks off the pipeline process. For example, a push request is made to a specific branch, and those are Git terms. So you're working on something on your Git branch, you do a push to that branch, push some new code, and that would trigger the pipeline to start. And then we have building actions taken to both build the product and the new feature. So build is like compile the code. And then we have testing actions that will test the project to ensure that the new feature does not interfere with any of the current features of the application. And then deployment actions: should the pipeline succeed, the pipeline progressed through the building actions and the testing actions, it passed any gates that were there. Should the pipeline succeed, the deployment actions detail what should happen with the build. For example, if the build succeeded, it should then be pushed to a testing environment. And then delivery actions: as CI/CD processes have evolved, the focus is now no longer just on deployment itself, but all aspects of the delivery of the solution. This includes actions such as monitoring the deployed solution. CI/CD pipelines require build infrastructure to execute the actions of these elements. We usually refer to this infrastructure as build orchestrators and agents. A build orchestrator directs the various agents to perform the actions of the CI/CD pipelines as required. These CI/CD pipelines are usually where the largest portion of automation can be found. As such, this is usually the largest attack surface and the biggest chance for misconfigurations to creep in and create vulnerabilities. And then common tools. So GitHub and GitLab provide CI/CD pipeline capabilities that are very popular. GitHub provides build agents, whereas GitLab provides a GitLab runner application that can be installed on a host to make it a build agent. For more complex builds, build orchestrator software such as Jenkins could also be used. We will explore these tools and their common misconfigurations in later rooms. I think I did see that we have a Jenkins room, so that will be good. And then here's our case study: a tangle between dev and prod. One common misconfiguration with CI/CD pipelines is using the same build agents for both dev and prod builds. This creates an interesting problem, since most developers will have access to the starting trigger for a dev build, but not a prod build. So typically there should not be a lot of access points for a prod build, but probably all of your developers, almost all your developers would have access to do a dev build. If one of these developers were compromised, an attacker could leverage their access to cause a malicious dev build that would then compromise the build agent. This would not be a big issue if the build agent was just used for dev builds. However, if you're using the same agent for dev and prod builds, an attacker can easily just persist on the build agent until a prod build is actioned, and then they can inject their malicious code into the build, which would allow them to compromise the production build of the applications. As always, the more separation, the better between your different environments, in my opinion. So what does the CI and CI/CD stand for? So that is, oh my God, I'll never be able to spell it. Let's just copy and paste. Continuous integration is the answer though. So here's continuous integration. What does the CD and CI/CD stand for? So in this case, they told us continuous delivery is kind of the most modern term. So let's try that. All right. And then what do we call the build infrastructure elements that controls all builds? And what do we call the build infrastructure element that performs the build? So that would be the build agent. And is this orchestrator maybe? Let's see. So maybe build infrastructure, and then there's build orchestrator. So if it's not, so I think the answer here is build orchestrators. Let me see the question again. What do we call the build infrastructure element that controls all the builds? Build orchestrators. All right, awesome. And we're going to see that in action, I'm almost certain, in future rooms. And then let's see, task 7 is about environments. So here's a reminder of our nice little environments graphic. Let's zoom in a bit on the pipeline section of environments. Most pipelines have several environments. Each of these environments has a specific use case, and their security posture differs and the security requirements differ. Let's take a look at some of the common ones. A common environment would be dev or development, and this is usually a playground for developers. This is the environment that is most unstable, as developers are constantly pushing new code, testing it, maybe doing like experiments in it. From a security standpoint, this environment typically would have the weakest security. Access control would be lax, and developers often have direct access to the infrastructure itself. Again, think just like minimum restrictions, maximum freedom, but there are often some guidelines in place in a dev environment as well. The likelihood of the development environment being compromised is high, but if there is adequate segregation and separation, the impact of the compromise would be low. And then here we have unstable stability, weakest security posture. May it contain customer data? No. Hopefully like the answer to that will be no everywhere but prod, but let's see what we find. And then we have a user acceptance testing environment. The user acceptance testing environment is used to test the application or select features before they get pushed to production. This includes unit tests that ensure the developed feature behaves the way we expect. This can and should include security tests as well. Although this environment is more stable than dev, it can still often be fairly unstable. And similarly, certain security hardening controls would have been introduced for user acceptance testing, but it's not as hardened as pre-prod or prod. So it's semi-stable. It has the second weakest security posture and no customer data, no production data. The pre-prod environment or pre-production environment is used to mimic production without actual customer user data. So you would often maybe hear this as the staging environment as well. And you want staging to be as similar to production as it can be, but sometimes that's not really possible because you're running lean, cost effectiveness, etc. This environment is kept stable and used to perform the final tests before the new feature is pushed to the production environment. From a security standpoint, pre-prod security should technically mirror prod, although this is not always how it goes. Usually, I would say deploying to pre-prod or staging, at that point, that should be automated. That shouldn't be a developer just pushing right to pre-prod. So this is a stable environment. It's the second strongest security posture, and no customer data would be the thing that differentiates it from production. And then we have prod, which is production. The prod environment is the most sensitive. This is the current active environment that serves users or customers. To ensure that our users have the best experience, this environment must be kept stable. If prod isn't stable, you are certainly losing money or losing time towards your mission or whatever you're doing. No updates should be performed here without proper change management. To enforce this, the security of this environment is always the strongest. Only a select few employees or services, so services would be like something automated, will have the ability to make changes here. Furthermore, since we may have malicious users, the security has to be hardened to prevent outsider threats as well. And production should always be stable. It has the strongest security posture, and it does have customer data. And then we have a disaster recovery or high availability environment. Ideally, you have this. So depending on the criticality of the system, there might be a DR, HA environment. And the idea here is this is an environment you can fall back to right away if there is some sort of problem with production. If switchover is instantaneous, it is usually called a high availability environment. And this is often used for critical applications such as online banking, where the bank would have to pay large penalties and basically have a gigantic like shitstorm if the website were to go down or if one of their systems were to go offline. In the event where some but very minimal downtime is acceptable, the environment is called a disaster recovery environment, and that's meant to be used to recover from a disaster in production. An HA environment should be the exact mirrors of prod in both stability and security. And again, that's ideal that it would be an exact mirror, but if you're a really small and lean organization, that might not really be how you're doing it. All right, and then other notable environments. There are some other notable environments you might hear about when you're talking DevOps. Green and blue environments. So green-blue environments are used for what's called a blue-green deployment strategy, where when you're pushing an update to prod, instead of having a single prod instance, there are two. The blue environment is running the current application version, and the green environment runs the newer version that you're just deploying. And then you use a proxy or a router. You first deploy to green, and then all the traffic can be switched to the green environment when the team is ready. However, the blue environment, you keep it up and running just as it was for some time, so that if there are any unforeseen issues with your new green deployment, you can just roll back to blue and you can switch all the traffic back to blue. We think of this as a high availability backup of prod during a new deployment to use for a rollback if something goes wrong, which is faster than having to perform a rollback of your actual whole production environment. So blue-green deployment is very common. And then we have canary environments, which is similar to green and blue environments. The goal of canary environments is to smooth the prod deployment process. Again, two environments are created and users are gradually moved to a new environment. For example, at the start, 10% of your users maybe would be migrated, their traffic directed to the new environment. If the new environment remains stable, another 10% migrated until 100% of the users are in the new environment. With the example of 10% of users, this would help you hopefully flag any problems with your new deployment with 90% of the users remaining unimpacted. So that would be the benefit of canary. These are usually classified under prod environments, but are used to reduce the risk associated with upgrading, making updates to your prod environment. You want to limit any potential issues and any downtime with new deployments, obviously. For common tools, we have environments have changed significantly in modern times. Breakthroughs such as virtualization and containerization have changed the landscape. They've changed the game. Instead of environments simply being computers, we can now have virtual computers created through tools like Vagrant or Terraform. We could also move away from hosts entirely to things like containers using Docker or pods or using Kubernetes, which I know that this learning path has a Docker room and a Kubernetes room. These tools can make use of processes such as infrastructure as code, which is also a room in this learning path, to even create software that can create and manage your different environments for you. And this is definitely like the modern way of doing it. As mentioned before, the security considerations become more important the closer the environment is to prod. The underlying infrastructure of an application also forms part of the attack surface of any actual application. Any vulnerabilities in this infrastructure could allow an attacker to take control of the host and the application. As such, the infrastructure must be hardened against attacks. This hardening process usually requires things like the following: removing unnecessary services, updating the host and applications, keeping everything up to date, and then using a firewall to block any unused ports. You should only have open the ports that are being used. So here's our case study: developer bypasses in prod. One of the common issues that can happen with different environments is that often things that should stay in dev don't. Developer bypasses are common in the dev environments for features like the following: MFA, multi-factor authentication, CAPTCHAs, password resets, login portals. Developer bypasses might be in place to allow developers to quickly test different application features by bypassing time-consuming features like your MFA prompt. So a common example is having a specific one-time PIN code in dev that's always accepted, regardless of the OTP code that would be sent by the application. So the example here in dev is that you just have one OTP you can just reuse over and over again so that developers can move as quickly as possible in the development environment rather than doing things like going through the MFA prompts. However, if there is an inadequate sanitization of these bypasses before the application is moved to the next environment, it could lead to a developer bypass making its way all the way into prod. So now in that situation, that OTP bypass, it can now be leveraged by an attacker to bypass MFA in your production environment and then compromise your user accounts. This is why it's so important that environments must be segregated, and similar to quality gates, security gates must be implemented to ensure a clean application is moved to the next environment. Which environment usually has the weakest security configuration? So that's dev. Which environment is used to test the application? So in the model they gave us, I think that was user acceptance testing. And then which environment is similar to prod but is used to verify that everything is working before it is pushed to prod? So I usually call this staging, but I think the term they used was pre-prod. And then what is a common class of vulnerabilities that is discovered in prod due to insecure code creeping in from dev? So that was the development bypass. What's the exact term? Developer bypasses. Let's try that. Yep. All right. So that is task 7. And then we're going to move on to task 8, which we can see here includes a static website. So this is going to be like some sort of more hands-on thing. So that will be good. Let's see what this challenge in task 8 is all about. So we have our static website here that we are going to open, and it says, open the site and build your own pipeline to get your flag. Use what you have learned to determine which concerns are valid at which stages of the pipeline. What is the flag received after successfully building your pipeline? Okay, and we got like a drag and drop thing going on here. All right, so we're gonna just rebuild our pipeline. So we know it ends with deployment to the environments. And then what is a potential security concern with environments? Hardening your environments based on their use case, having too many different environments, a developer bypass making its way into a prod environment. Well, can we select more than one? Because I would say, I guess it depends how you define security concern, but I'm gonna go with a developer bypass making its way into a prod environment. Okay, and then so we know the pipeline begins with source code storage and version control. What is a potential security concern with source code storage and version control? Developers committing code to the storage. No, that's like the point of what's going on. Secrets being committed to the source code, yes. Developers pulling code from the storage. No, once again, that's what's supposed to be happening. So secrets being committed to source code. And then in our original pipeline diagram, I remember dependency management was right here associated with source code storage and version control. So what is a potential security concern with dependency management? An outdated dependency that has a known vulnerability is being used. That's definitely true. That's definitely a big concern. It's something that happens a lot. The application having too little dependencies? No. The dependencies being developed internally? No. So this is our concern, an outdated dependency with a known vulnerability. All right. And then from the source code storage and version control, we go to the continuous integration. Let's see. A potential security concern here, an automated code testing tool being used as a replacement for penetration testing. Well, that certainly isn't ideal, but I don't know if that's the security concern. An automated code testing tool finding a vulnerability. No, that is good. That's what you would want to be happening, I think. And then using an automated testing tool to perform static or dynamic analysis of the application. So no, once again, that's what you want to be happening. So I'm going to go with an automated code testing tool being used as a replacement for pen testing. All right. And then lastly, well, not really lastly, but the last one I'm doing, associated with continuous integration is the automated testing. And the potential concerns here, having more than 2 build agents. No, that's okay. And in fact, if you have a lot of different environments, like they were explaining, you want to have a lot of different build agents. A developer triggering a dev build for a new feature. No, that's what's supposed to be happening. And then a build agent building code for both dev and prod. Yes, this would be bad and a concern. All right, so that was all right, clearly, because we got our flag pipeline automation is fun. I agree with this. I think it is really fun. I think it's like one of the most fun things about DevOps. And let's see. All right. So task 8, our challenge is complete. And task 9 is the conclusion. This says automation in the pipeline has significantly increased the capability of SDLC processes. It has enabled developers to rapidly create and deploy updates to applications. However, these new automation, I think it's supposed to say automations, can also lead to an increased attack surface since an attacker can now indirectly attack the application by compromising its pipeline. Implementing secure automation is therefore needed to ensure that the automated pipeline does not increase the risk of application compromise. Throughout the various rooms in this module, we will take a deeper dive into the elements that make up a pipeline and show how security can be applied to each element of the pipeline to create a more secure automated pipeline. So that was our introduction, and then now we're gonna really get into it. So that completes the introduction to pipeline automation room. That was another good room, a lot of really good information. And the next room on this learning path is the source code security room. I will be looking forward to that. Thank you so much for watching this video walkthrough. If you watched, I hope you're enjoying the videos. I'm definitely enjoying making them. It's just like a great little nerdy fun thing to do. I'm just going to keep cranking through this DevSecOps learning path. So maybe I will see you in another TryHackMe room walkthrough soon.